In this video, we discuss about the stack involvement in recursion. Whenever we call a function, then the function, a copy of the function is created and it will occupy memory in the stack, and the local variables declared in that function, they will get memory, or they are allotted memory in the stack. Stack is nothing but a portion of a memory. Now in this example, we have a main function, and main function is calling a function with two values 10 and 20. In the a function, it is having some base condition, that is, if a is less than 15, then it is calling the same a function with values a plus 1 and b plus 1. Now we see how these functions are called and how they will occupy memory in the stack. When we execute this particular program, the first function that is called is the main function, and main function will occupy memory in the stack. Any variables declared, any local variables declared in the main function, they are allotted memory in the stack. Now assume that in this example, main function is calling a function with values 10 and by passing values 10 and 20. That means now a function is called, a copy of a function is created and will be placed in the stack, and all the variables declared in the a function, they will get memory locations. Now in this example, a function is called with values 10 and 20. Then two local variables are created, they are allotted memory with values a is equal to 10, b is equal to 20. Now in the a function, it is checking a value. If a value is less than 15, then it is calling again a function with values a plus 1 and b plus 1. In this example, a value is 10, that means 10 is less than 15. That's why it will call a function again with values 10 plus 1, 20 plus 1. That means it will become a of 11 comma 21. That means again a function is called. Another copy of a function is created and it will be placed in the stack. Now another set of variables a and b are created, which are local to the function a of 11 comma 21. A value becomes 11, b is equal to 21. In this case, a value is again less than 15. Then it calls the same function a with values 11 plus 1, 21 plus 1. That means a of 12 comma 22. Another copy of a function is created with values 12 and 22. Then the local variables of a function, again they will get memory locations with values a is equal to 12 and b is equal to 22. In this example, a value 12, which is again less than 15, then it will call a of 12 plus 1 13, b plus 1 23. Another copy of a function is created and the local arguments a and b, they will be allotted memory locations. Again a value is less than 15, that is 13 less than 15. Again it will call a function with values 14 and 24. Another copy of a function is created with values 14 and 24. Now a and b, two variables are created again with values 14 and 24. Here 14 value is less than 15, that's why it is calling a function with values 15 and 25. Now last one, a of 15 comma 25. Now observe here, there are different types of variables created, a and b. These a and b functions, they are local to this particular a function. Here a and b, they are created and these are local to this particular a copy function. And here a and b variables, they are local to this particular function. In this fashion, whenever a function is called, the local variables declared in that function, they will be allotted memory. All these a and b variables, they are different variables from other functions. In the last case, a of 15 comma 25, a value is 15 and b value is 25. Now in this particular case, what is the condition here? A value is less than 15. Now 15 is not less than 15. That means at this point of time, the recursion will be stopped. Here there will be no more function calls. This is the purpose of base condition. It is used to exit from the recursion. Now, once this function is completed, now a of 15 comma 25, once this copy of the function is completed, then it will be removed from the stack. Now when this copy of function, that is a of 14 comma 24 is completed, it will be removed from the stack. In this fashion, once a function execution is completed, then its related code and all the local variables all the local variables declared in that particular function, they will also be removed from the stack. That's why the local variables declared in a function, they will not be available to other functions. Why? Because they are removed from the memory once that particular function is completed. Now once a of 13 comma 23 is completed, then it will be removed from the stack, and once a of 12 comma 22 function is completed, again its related code and all its variables are removed from the stack, and once a of 11 comma 21 is completed, then it also be removed from the stack, and once a of 10 comma 20 is completed, then it will also be removed from the stack, and finally once the main function is completed, then also it will be removed from the stack. In this fashion, whenever a function is called, then it will occupy memory in the stack, and the local variables declared in that function, they will get memory locations in the stack. Once that function execution is completed, then it is removed from the stack, and all the memory locations which are allotted for variables in that function, they will also be deleted from the stack. This is the concept of stack involvement in recursion.